So I'm going to start off with Backstage, and you'll notice that it looks very similar. I'll show you the Tanzu Application Platform in a second, but it looks very similar. There's a very similar sort of navigation layout. There are even some things that look extremely similar, like the settings page, for example. So if I switch over to Tanzu Application Platform, this is our GUI, and the settings page is very similar. So we've got the same options around, which theme you would like to apply, the profile, the authentication providers, etc. So already you can see that we are clearly based on Backstage, and there is no doubt about that. We love Backstage, we're very supportive of it, and we are actively participating in that community and contributing our ideas and our code back to the Backstage project as well. So we love Backstage, we think it's great, and we are using it actively inside some of our flagship products like Tanzu Application Platform. We also have a similar thing here with the catalog. The Backstage catalog is there. We also have the same sort of thing in Tanzu Application Platform, but it has been expanded. We've done some extra things to the catalog that are pretty unique to the Tanzu Application Platform and that allow folks to get more context about the applications that they're running on Kubernetes and where they live and how they're operating. And then some other things that you'll notice is, for example, the system view. System view exists in Backstage. It also exists in the Tanzu Application Platform. You can go through, find a particular system, get a diagram all about that system, find all the components that are communicating and collaborating in delivering that particular service to customers, and you can view the same sort of graphs and stuff. We can do that also through regular Backstage. So if I have a look at this system here, for example, take a look at the diagram, it's very, very similar, same sort of stuff. Okay, so that's vanilla Backstage. This is Tanzu Application Platform. Let's start looking at some of the things that are slightly different, and the Tanzu Application Platform has been designed to try and deliver to teams to help them stay productive. How do they actually first of all get started on a piece of code, but also how do they share things like patterns, etc., amongst themselves and with other teammates? And we've designed application accelerators to help us do that. Now, accelerators themselves are custom, so our clients can write their own accelerators. I've got a selection here of about 15 or so, but there's no limit. You could have as many as you wanted, and they can cover as many different programming languages as you like as well. The idea with each one of these is that they provide a template. So each one of these tiles on this screen here is a template for a particular type of project. If I choose one, for example, if I go for this RESTful web app here, for example, I can take a look at that. It allows me to pre-configure this particular template, and then I can click next. It asks me if I want to create a Git repository. I'm not going to in this particular case, but you can. And then it would allow me to generate that particular accelerator as well. When I generate it, it's now creating for me all the code that I need to get started with that particular project. I can also explore what's been generated for me. So this is good because it gives me the opportunity to show to you folks all the work that's gone on in the background to create this template ready for a developer to use. And the template itself is quite comprehensive. This particular one is a Java web app, so I'm using the Maven packaging system, and everything that I need, all the packages that my organization thinks we should use are contributed to this particular piece of source code already. So I've got dependencies for database access, for metrics, for web access, for things like REST. It's all here already. It's also done some things like creating a Docker Compose file so that if I want to test locally, I can do. I also have in here source code, so I can quickly take a look at the source code that's been generated for me. Oh, pardon me. just click that carefully. There we go. Clicked it carefully enough this time. I've got all the usual stuff, including an API definition. So out of the box, I've got an API definition that follows the OpenAPI 3 specification. I also have some things that help me with Backstage. For example, a catalog file, which allows my application to be listed in the catalog that we saw earlier. And then I've also got some configuration. This particular item, this workload YAML, this describes this workload so that the Tanzu Application Platform can just take this one file and this source code and build and run the application on the platform for me without me having to really generate any YAML deployments or any of that stuff. The services, I don't need to write all the usual YAML for all that stuff. It's going to generate all that for me because I've got one of these files that defines how this workload runs. So yeah, there's a whole ton of stuff here, and this can be written by anyone. So any team can provide an accelerator that could help themselves or any other team inside the organization to use the same patterns, to use the same libraries, to use the same conventions. All of that stuff can be captured. All that great knowledge can be captured and publicized inside these accelerators that live inside the platform. In addition to that, we've also got the API navigator that allows you to take a look at the APIs that are offered inside your organization. And if I drill down into some of these, you can see the full OpenAPI specification for one of the components that's been deployed onto the platform. This can happen automatically too. If your application defines an OpenAPI spec, then it can be picked up by the platform as the workload is run and added to this list of APIs automatically. So there's very little that you need to do as a developer in order to make this happen. But it gives you the usual kind of swagger definitions. You'll be able to go through and find out what the different payloads are, for example, and all the different endpoints and which methods to use in order to work with those endpoints as well. So a whole bunch of stuff around APIs in here too. Let's move on to the run aspect. Remember, we were talking about sort of start, run, and manage. Let's take a look at run now. So how do workloads get onto the platform? They go through a supply chain. Now, a supply chain is a secure pipeline, if you like, that takes a piece of source code and turns it into a running application running inside of Kubernetes. And that's what all these applications here, they've all been through a supply chain. So if I just pick one off, say I look at this gateway here, this particular supply chain is quite good, I think. It's got a lot of stuff in here, so I'll talk you very quickly through the whole lot. So we have the source provider. This is a trigger, if you like. It's watching GitHub and it's waiting for changes on a particular piece of source code. And then as soon as those changes appear, it will take the code, check it out, and run a test on it. And this test varies. So if you're running Java, it would run tests in a Java fashion. If you're running Python, it'll run tests in a Python fashion. So it's very flexible. You can use the same supply chain for lots of different things. Then once that's passed and the application is almost ready to be built, we'll go through a security scanner. So we'll run some scanning on the source code to find out what are the dependencies inside this piece of source code and what vulnerabilities do they have. And there's quite a few vulnerabilities listed out for this particular piece of source code here, but it also gives you a mechanism to go and check those, and I'll show you that in a little while. Then it will build an image for us, so we don't need a Docker file. The application can automatically be built into an OCI compliant container, and it will use a hardened operating system inside that container as well to limit as far as possible all the security vulnerabilities and prevent us from having that sort of sprawl that you get when every team's got a different Docker file. So we're using an open source CNCF project called Build Packs to do this. Go and take a look at Build Packs if you haven't before. I highly recommend it. They are way easier to use than Docker files. What else do we have? This image, of course, added an operating system, so we have an image scanner. In this case it's Gripe, but we also have integrations with others like Sneak, for example. This is checking the layers in the OCI image to make sure that there haven't been any vulnerabilities introduced by the operating system or any of the sort of sub layers of the image. Once we know that's okay, we go through config provider and application config, where essentially we're starting to build all the information needed to run the application on Kubernetes. And then we also check for any service bindings. So if there are anything like databases that need to be configured to connect to this particular application, then we can do that in the service bindings. And then finally, we go through API descriptors to add any APIs automatically to the API list that we saw earlier, and then the config writer. Config writer is creating all the configuration needed to run this particular application on Kubernetes. It will use, for example, things like it will have all the usual Kubernetes stuff in there. So everything that you're used to with when you're running an application manually on Kubernetes, you know, you're configuring things like the result sets and the services and all that sort of stuff. It's got all of that ready to go before finally it's turned into a workload and then delivered onto the platform. Once it's delivered, then it's running. We think that supply chains are really important. They're a way that teams can get that sustainable pace that they need, because they can hand off source code to a supply chain. The supply chain will take care of the rest. But at the same time, it's also very secure. Operators and security teams can help to create these supply chains. They're very flexible, so they integrate with lots of different tools, and you can have different application source code types go through the same supply chain as well if you want to. So you could have one supply chain that does Java and Node and .NET, or you could have different supply chains to treat those things differently. It's entirely up to you. Behind the scenes, there's an open source project called Cartographer, and that is helping bind all this stuff together, provides us with the mechanism that we need to link all these different stages in the supply chain together. So what is in Kubernetes? What physical pieces are running in the cloud somewhere that are related to my application? So if I go through and take a look at the gateway, I have this tab here for runtime resources. And in this runtime resources, I can now see all the different items that are associated with this particular workload. If I take a look at the pod, then I can see, for example, everything that was applied in order to get that pod to run. So I've got my workload deliverable, I've got the service, I've got the deployment, I've got the replica set, I've got the pod itself. I can also see the logs for the pod, so I can take a look. If I think there's something that I need to see in the log, I can go and have a look at the log. I can even change the log levels live, so I could maybe go and change the web package up to debug rather than info where it currently is. So I can start to interact with the application as it's running on the platform as well. Let's take a look at something else. So if I go through the Knative service, inside this platform is Knative. Knative allows us to, it's another CNCF project, allows us to scale to 0. You probably know that already. But this is where I'll find, for example, my URL for my running workload. So I can start to interact with it and begin to use the application that's been deployed. I can view the YAML that was created in order to drop that onto Kubernetes, and I can take a look at some more information. If I go back to the pod again, I can see live information about what's happening right now on that particular application. So what is its API success rate? How is its environment configured? What variables is it expecting does it have? So for example, here I can see that my config server is living at this particular URI, and I can see which ports have been configured and which JVM is being used for that particular application. Everything you'd expect to know about the environment is here. I've also got HTTP requests. I can look at the different beans that are configured inside this Spring application. I can check the health and see, okay, config server is up. Discovery composite. I'm not using discovery, so that's good. It's not needed. So yeah, lots and lots of information about the current workload and all the different parts of that workload is all exposed through this UI, which is based on Backstage. Finally, let's take a quick look at two more pieces I've got for you. Technical documentation. Again, this exists already on Backstage, so you can see this in the Backstage demo, but it's a, documentation is a nightmare for teams. It can be everywhere. We have documentation in wikis, intranets, Word documents, I don't know, thumb drives. It could be anywhere. I've worked in teams where this kind of sprawl is a real problem, especially for architects as well. If you're trying to piece together all the different pieces of information about a system in order to create something new or design something new, it's an absolute nightmare to go and gather that stuff together, because half of the time, even when you found it on that wiki or intranet, it's 3 years out of date and no longer relevant to what currently happens in the organization. So by exposing your technical documentation alongside your source code and then through the Backstage UI, you can share that widely amongst all the teams who can get into your Backstage. So they can all share the same contextual information about how the application's been built and how it's run. All that good stuff can be shared more widely, so you can share that knowledge across your teams. And then lastly, how do we manage the applications while they're running? What can we do to help teams to understand, for example, security vulnerabilities that could change on a daily basis? Well, we've added a vulnerability dashboard in here into the UI that gives us a view of all the different applications that are running and where they stand in terms of, do they meet our policy or do they not meet our policy? All the applications here do meet our policy. If any of them didn't, the supply chain would not allow them to be run on the platform. So the policy is applied to the supply chain as well as to this security dashboard that we're seeing here. None of these violate the policy, but if I go through and have a look at one of the components, I know I'll have vulnerabilities on the component because there are always false positives to deal with. CVEs are not it's not black and white. There's a certain amount of gray in there, so I know that, for example, I have this particular CVE on this application. The reason I have it is because of a false positive when the scanner, so we're working with the scanner to improve its detection of these types of applications, but it also allows me to go straight through to the vulnerability database and take a look at that as well. So I think that's it. I think I've shown you all the way around the Tanzu Application Platform GUI. I think I've shown you how it relates to open source Backstage as well, and the similarities between it. And all that really remains for me to do is to give you a few links for if you want to find out more about our work with Backstage or with the Tanzu Application Platform.